Good morning and good afternoon to all of you. Welcome to the Fundamentals of Data Visualization webinar. This webinar is part of Tableau's Visual Analytics webinar series. We will be looking into why the cognitive system is suitable to help us visualize data. My name is Jacelyn Lim, Senior Product Consultant based in Tableau APAC office here in Singapore. This topic really excites me a lot. I too got those mind-blown moments where most of the things we all have knowledge of, but because we aren't really conscious or aware of, we couldn't leverage or apply it on our day-to-day work. So I hope at the end of today's session, you will also get inspired to look at your work or analytics with a new perspective. So if you have any questions along the way, please feel free to type in the Q&A box and we will get into those questions towards the end of the session. Now, before we begin, there's a couple of things that probably we will revisit or repeat several times. And this has got to do when you're sharing your insights with data, and it is all relevant to these following questions. First of all, who is your audience? Will the audience be able to understand the type of charts that you're building? Have they just started out their analytics journey and they may not be able to understand some of the more fancy or complex chart? How much data literacy skills does your audience have? And also, will your audience be willing to put time in understanding the charts you've built? Because the charts that you built for dashboards for a 5-minute meeting presentation can be radically different from an operational dashboard that's built for the operational team or analysts due to the difference in details and the way it's presented. So, are you building a chart that's relevant to your audience? Also, you do need to consider what is the purpose of your dashboards, or what is it that you're trying to tell your audience. There are so many data and important information to present. We all understand that. But the key to helping you stay focused when building a dashboard is actually the purpose of your presentation. So this can be a bit of a combination of art and science, where you will be like the journalist, but instead of expressing it out using writing with just words, you are using visual objects like charts to convey a certain message. So in a moment's time, we'll be going through the science also on how to apply that to our data. Now, quoting from the authors who wrote the big book of dashboards, when they are writing, they came up with this goal in mind if you are doing any analytics or data visualizations. So the main aim is that your dashboards or analytics can cater for the largest amount of people and provide them with the greatest degree of understanding with the least amount of effort. And the least amount of effort that they are referring to here in this case is the audience of effort in understanding your data. They shouldn't have to scan through the entire dashboard and try to decipher what you're trying to say to them. So the best goal indeed would be that when you pass your dashboard or your work or analytics to your audience, without speaking a word, they should be able to understand and get at what you're trying to achieve in your dashboards. So that's the ultimate goal. And of course, with that goal in mind, our audience is definitely another human being. And therefore, understanding on how our brain works definitely would help us. So we should always take advantages of our cognitive system. So the following slides and section will provide as a foundation ideas when we are exploring what type of charts is suitable for conveying certain types of information. Now, this is our brains. But don't worry, we do not have to go through the different parts of our brain like in the biology classes. So what we want to say here is that even though in terms of size, the brain seems to be one of the smaller parts, but with many different components working hand in hand together and wired together, connected to also our eyes, it is a very remarkable organ. So evolution have given us these organs to help us to actually understand what is going on around us and the environment around us. And also, because there's so many things going on around us, so many visual signals that our brain will pick up, our brain have evolved to make our life easier, such that it filters out some of the less relevant information so that we don't get overwhelmed by all these visual cues. And that could also be a trick that our eyes or our brain is playing on us that we don't actually see. So I have two examples here to also show how wonderful our brain is. Yeah, I'm sure most of you may have came across similar eye tests on the social media. Are you able to read these tags? Don't you think it's our brain, it has really great efficiency? So we are not focusing on each individual wordings, but actually how the overall words or patterns looks like. We can completely read these bunch of texts without much difficulty. Or in the case where there's a split opinion on the internet about a color of the dress. So whether this dress is white or blue. So you can see that based on how brain is wired or based on lighting, you may see this dress in a different way. Yeah. So there's nothing that we can do to stop the advantages or even the pitfalls. But what we can do, as we'll see in the data visualizations, is to lean things towards some of the benefits that our brain can leverage on and avoid those pitfalls. So as wonderful as our brain is, it can also be flawed. So here I would have two examples to show you. So in my next slide, I'll be showing you a picture. So in this picture, well, you can put your hands up physically when you're in the office, or you can simply type in the chat as well once you have seen the toothbrush. Okay, so here I will flash the picture. Yeah, so are you guys able to spot the toothbrush? Yeah, I'm sure most of you must have. I've seen some of you typing in the chat already. Yeah, but then hands up again for those who have seen two of the toothbrush, not just one, but two of them. Yes, have a closer look. Okay, so here, we have a toothbrush right here in the middle, just on the tabletop, as most of us would have expected the location of the toothbrush. And then let's take a look at the bigger toothbrush, which is sitting right at the back of the screen or the picture. Really huge toothbrush, but it's more difficult to see, or some of us or most of us may have missed it until I've mentioned that there's actually two of the toothbrush. So what we are seeing here is that our brains are fooled by what we are actually looking at. And what's happening is that our brain is trying to understand contextual information, while of course ignoring some of the things that can be pretty obvious, but we are blind to, because of, firstly, the familiarity that we know roughly what size of toothbrush is like, and in the context of a toilet, some typical location where a toothbrush maybe would be the one that you have already seen in the middle of the picture, while ignoring such a huge toothbrush that's actually behind the scene. Yeah. And in the next example, I will be showing you two pictures as well. So in between, it will be a flashing picture. So if you see the screen flashing, is completely normal. Yeah, and it will flash between two versions. And what you need to do is to spot what is the difference between the two different picture. So here we go. So did you guys manage to spot some difference? Yep, so for those who have not spot any difference, if you're feeling a bit nervous, you don't have to panic, because the good news is that we are evolved to fail at this task. And for those who have seen it, great job. So a plane requires an engine to fly. So keep your eyes focused at the position where the plane engines are. Yeah, you can see that it actually disappears in the next moment. So what is actually happening here is that the gray flashes between the two images essentially clears out the brain's short-term memory. So each time your brain sees that picture, the brain is actually seeing a completely new picture. And therefore, because of that gray flash, we have forgotten what we have seen. And it's so much harder to focus on what is the difference between the two pictures. So this itself can be another problem with the cognitive system. We don't see information if we look away from it and then suddenly some of the things change. And some of you who have sharp eyes, you may also see that at the tail of the plane, the flag or the logo of the plane is also slightly different. Yeah, but other than that, the main focus is the plane engine right here. Yeah, but definitely our brain is also amazing. And some of the examples that we see here. So in the Amsky quartets, so this is a very famous statistician who have created what he called the quartets of group of numbers. So his ideas back in the 1973 is to emphasize the importance of graphing out the data before analyzing it, and also to look at some effects of outliers. So while he was very certain that the number calculations can bring exactness to the analysis, graph would definitely show us a great deal more. So let's take a look at the examples. So these are the numbers from group A all the way to group D. So can you see any kind of trends or pattern from this table? Yeah, probably it will be much more difficult to spot that. However, if we were to put all this information into a statistical programming tool, so what the computation would tell you is that all these 4 groups of numbers have the same statistical properties. They have the same mean, correlation, sample variance, and even linear regression line. But if we were to plot them directly on a chart, so we can see that this is group A, group B with a curve, group C with a straight line and one outlier, and then we have group D. So as we can all see, it's fundamentally different. So what he's trying to say is that you can't just rely on stats, because stats, if you're looking at these data from a statistical perspective, they are all the same. However, if we look at it visually, we can tell that all these are definitely different, and this is something that the machine can't really tell us at this point. And fast forward to 2017, we have Justin and George taking the same concept and experiment, and then they amp it up with programming like Python to basically put in the image and force a scatter plot so that the machine actually can churn up statistical information and also X and Y coordinate that has similar properties. So you would see that if we were to go through the different shapes, all these shares again the same type of properties like mean, standard deviation, and correlation. However, visually we can tell that it's completely different. We can have stars, we can have oval, we can have a dinosaur, or even random lines. So visually, it takes human beings milliseconds to realize each of these are completely different. So let's think about nowadays we are talking about artificial intelligence and machine learning. We are increasingly putting numbers into these machines and assuming that their algorithm can detect the difference. But if we choose some weak algorithms like a mean, standard deviation, and so forth, it can be potentially misread. And all these can actually be easily detected by our human eyes in less than a few split milliseconds. So the experiment in the 1970s versus the experiment that is done in 2017 proves the same point that our visual and our cognitive minds are really important to the analytics process. And this is why we should visualize our data. Now, human has to definitely be in this loop of when we're doing analysis. So next we'll be looking at the information based on to find out what is the biggest value and also what are the trends. So here we have two sets of data from 2013 quarter 1 and all the way to 2016 quarter 4 for the different product categories, furniture, office supplies, and technologies. So again, are we able to find out which has the biggest value for a particular category, and also what are the trends across the years? Is my furniture sales going up or down from 2013? Yeah, it will probably take you a longer time to try to find out what are the answers to these questions. But let's see if we can put it into or present it in a different way. Now, based on our line chart. So now, but to answer the same questions, which has the biggest value, we can very clearly see that in technology, in the year 2013, has the highest sales. And it also has the sharpest fall between 2013 to 2014. And while furniture is second in line, it actually overtakes technology in 2016. Yeah, so what we are looking at here, very quickly, we can answer several questions just by looking at our data in a different way. Yeah, so the next very important aspects of why we visualize data is not just to see the insights of this data, but it's also to leverage on what our brain processes, what we call chunking. So if we were to refer back to the table now at the top, what we are trying to see, or what the human brain is going through when we are looking at the numbers, is to put each individual set of numbers into, again, our short-term memories. And for us as humans, the maximum amount of information that we can hold in our short-term memory is about 7. And as we are moving along the data set, the more number we try to put in our head, the more we will forget after looking at the others numbers. So what chunking allows us to do is to contain the entire line of numbers in our short-term memory. So if we are, in this case, looking at the line chart, this entire line that is plotted on the line chart is placed into our brain as one single chunk. So definitely it's much more efficient when we are, in this case, storing information into our brain, our short-term memory. So that is why that when we are looking at charts and graphs, it's so much easier than to find trends, find outliers, than to look at the tables themselves. But of course, if you're trying to find out data details, then you may want to look exactly at the tables instead of the graphs. So this is what we are doing. As Andy Kirk of the Visualizing Data says, it is the representations and presentations of data that exploits our visual perception abilities in order to amplify cognition. So this is exactly what data visualizations to him is. Yes, and get that right, and all the data in your spreadsheet, data warehouse can be seen and also explored for insights. So now let's take a look at how it actually maps to our data. Now, for those of you who may have attended our test drive before, you may have seen these questions before. So again, I'll be showing you a picture next in the next slide, and you have to find out how many 9s are there on the screen. Okay, let's go. Great, I already see some response on the chat. Well, it's quite hard to answer these questions without scanning through each individual digits, because that's what our brain is trying to do. Go through each individual digits and try to count the number of 9s. So let me make one change to make your life a bit more simpler. Yeah. Are you able to count now how many 9s are there in a much quicker fashion? Well, there's a total of 13 of them for those who are curious or those who have already counted them. Yeah. So the point is, now that I've shifted the focus, highlighting the 9s that we want to find out in a stronger color and fading out those that is less important, it is able to capture our eyes, and therefore it's much easier for us to process this information. So what about another way to show this information? We potentially can place this into a bar chart as well. So we can tell from here that the number of 9s in this set of numbers is 13 of them. And based on that, we can also tell that the number 6 contains in the picture the most, that appears 21 times. So these are the information that or insights that we can get if we have placed things visually. But of course, this is not true data, but what essentially we're trying to focus on to tell you, and is also that by leveraging on things like colors or even the length of the bar to indicate the value, can help us to, as humans, to very easily and quickly look at the information and process the information. So color and length are two sets of very special features called the pre-attentive attributes. So pre-attentive attributes are the visual features that we as human beings can process subconsciously. So as I flash this screen, most of you may already spot some of the difference or outliers, such as the length of the length of this bar is longer than the rest. This bar here is thicker, and this has a different color compared to the rest. So these are what our brains are doing without us knowing. It just happens automatically, and even before we can consciously make to think about things. Yeah. So therefore, by leveraging on these set of pre-attentive attributes, we can basically, it forms the basic building blocks for all our charts that we are using or what we have built in Tableau. So many of you may also ask, there's so many types of pre-attentive attributes: shape, colors, size. So which of the pre-attentive attributes are the best? So pre-attentive attributes, they help us to aid our cognitive system, but of course not all the pre-attentive attributes are built the same. So I have two examples here to illustrate that. Okay, so we have two different diagrams here. The chart on the left is using the size of the bar to indicate the value. So we can see that A, being the longest bar, has a value of 150. Whereas on the right hand side, we have the bubble chart, and also again, it's using size of the bubble. So as the value, so F has the value of 200. So now your task is to have a quick guess or guesstimate of what could be the value for D and H. Yeah, so you can type it in the chat or just have a quick guess and keep the numbers in your head. Okay, so we have conducted this experiment or this quiz through the different workshops or different sessions, and we too have collected the information and we are going to share with you the results as well. So how much is D and H exactly? So the answers are, for D it's 45, and for H, the circle, it's 35. So have you guys got them correct? Or the difference of +5 or -5 is great too. Yeah, so we have run this through for 1,407 attendees, and these are the results of the response that we have gathered from them. So we can see that for the first chart or first graph here, most of them have the answers correct, this is the histogram. So it shows the distribution between the guesses, the results that they guessed. So most of them actually guessed it correctly, between 40 to 50, or some would be a bit off, of 50 to 60. But if you compare to the circle, so the correct answer is 35, which should fall within this group. We have a lesser number of people getting them this right. So most people either guess a bit too less or a bit too much. And you can see that the accuracy based on the response, or the distribution based on the response, is very different. So if we are using the length of bar, when we are using a length of bar, in this case, it is much more accurate for the human's eyes to gauge the values as compared to things like size of bubble or circles in general. Yeah, so congratulations to those who managed to figure the values out. Yeah, so also, but that is not to say that we shouldn't use the bubble chart for our analytics. So here's the example. So this is taken from The Economist for the Halloween season in 2017. Yeah. So what this is showing is the number of people who got tried, accused, or executed for witchcraft in the European countries. So what this author is trying to present to you is the focus would be on each individual European country for the number of people that has been accused and executed. These are the primary information that this author is trying to convey, which he already used the bar chart, which can help us to have more accurate estimates. And for the secondary information that he also wants to present, and as well as to save some space using bubble chart, the size of the bubble, that is to showcase the ratio of the witchcraft trials per 100,000 people. Yeah, so we can see that for his purpose of illustrating or focusing our attention on the number of people accused or executed, is presented in bar, whereas less important information could be using the another type of attributes, which is the size of the bubble. Now, so this can also be easily replicated in Tableau. So this is built on Tableau directly, bar versus the bubble. So just a very quick guess on what could be the numbers for Scotland. Aha. Did you guys get the numbers right? So Scotland is about 3,563 for total number of people accused, and the ratio is about 509 per 100k of people. So when you are visualizing your data, it is really most important to keep focus on your purpose, like we've mentioned earlier in the presentation, the purpose of your what you're trying to present, and also who's your audience, and that will help to guide you to select the right kind of charts or visual objects to use for presentation. So here I have another example as well. So this is the Iraq's bloody toe. So this is taken from the South China Morning Post, posted by one of the journalists way in the 2011. So what we can strongly see here is that it is an inverted bar chart, and the author have chosen things like red color to show us the strong, visually very bright color, to indicate that this could be, or this can be what it looks like, blood dripping down from the top of the chart. Now the axis here runs through from 2003 all the way to 2011, from left to right. Now, if we were to just swap things around, let's rotate this chart around back to how we would normally view. So now the latest information, or the latest year, is actually on the left hand side. So we are reading from the right to the left. And if we were to look at this chart now, what we are seeing is that actually from the year 2007 onwards, the number of blood toes, actually it's on decline. So just based on the orientation of a very simple chart, and also the use of the colors, it can invoke a different feelings or even emotions that us as the audience may feel or see when we are looking at this information. He did not, however, make any changes to the data itself. This is exactly how the data should be. But by changing some of these visual cues, it has given us more information without us exactly are really conscious of, until we are looking at this very specifically. Yeah. So there's also a study done by Alberto on the types of charts or graphs that can enable us or the audience to have a more accurate estimates. So if we were to look at the top on the list here, that enables us to use accurate estimates. So we would see that most of the diagrams or charts could be very familiar to most of us. It is based on the same common axis or scale. We are using things like line graph, bar charts, or scatter plot, or distribution, even histogram. So leveraging on things like the length of the bar to help us identify the numbers that we're trying to present. And if we to look down into the lowest end of the scale, we are looking at the properties such as volume, shading saturation, or even the color hue. So these may be less effective when you're trying to present more important information. Therefore, if you are presenting something that's of it's not the main focus, but maybe a secondary focus, you may then want to use things like volume or even shading and colors to do that. Now let's map this to the data. So typically our database would contain three types of such data. First would be the categorical data, ordinal data, and quantitative data. So we'll take these three types of data and map our Game of Thrones data using these pre-attentive attributes. So what we are looking at here would be the list of the Game of Thrones season episode titles. So these are taken from imdb.com based on the fan ratings information. So each of these are not specifically arranged in any order other than the alphabetical order. So all these informations here would be the nominal type of information, where it describes the things, objects, in this case the episodes. So it is usually the distinct categories of things. So all 67 episodes here are just encoded based on their position, where they are located right now. But there isn't any other information. So now we have changed, or rather we have encoded or color coded these episode titles using the colors which depicts the seasons, and we've also arranged them based on the seasons within. Yeah. So these are our ordinal data. So ordinal data are also like things such as the episode, but we are using the seasons to order them. Ordinal data is actually numbers, but just that they have a particular season, a particular sequence. So season 1 followed by 2, 3, 4, and so forth. And in this case, the ordinal data is mapped using position as well as our colors. Now, if we were to also rearrange this information, we could be using things like our quantitative information, which is usually what we use to analyze our data. So we would take the fan ratings for per episode and then use that as a position for all the different episodes. So we can see that the rating is on the left-hand side for the scales, and most of the episodes are actually above a rating of 8. So everyone seems to really like Game of Thrones. So position is used to encode these quantitative data, and quantitative data can be aggregated and summed up, or even computed. Like you can find out the average rating, how much is it, or you can find the highest maximum or the lowest minimum rating that has been given. So these are the quantitative values. So categorical information is used as position. Ordinal can be used in positions and colors in this case. And the quantitative value, such as the rating, is used as the positions, where we position each of the individual bubbles. Yep. So we've talked about the importance of pre-attentive attributes and why when we look at the charts we can see those stuff if it's designed well. So now with the different types of data, you could think about how to best represent your information. And this is what Tableau really does really well. If you are using Tableau, you would know that you are able to iterate through the different types of charts and choose the right type of your pre-attentive attributes to actually represent your data or try to convey the message that you're trying to push through. And of course, we can also see here that there's actually an outlier of episode 46 for these examples here. So the title is Unbound, Unbanned, and Unbroken for episode 46. So despite it having the lowest rating, it still has the rating of 8.1, which is pretty good. So for those who have watched the Game of Thrones, do you agree that episode 46 is actually one of the lowest rating among the entire season? Now, to just recap, we have looked through the power of our cognitive system. Our eyes can see pre-attentive attributes in a very powerful way. We can take those pre-attentive attributes and encode data using that. So we can use length, color, size, or even positions to encode the data. So for the next part, we'll be doing a mini exercise. Well, of course, now we are all online, so you can actually have a thought about it or build the charts in your mind. Or if you have pencils or papers, you can also just simply draft out or draw out the charts. Yeah. So here's the data for the market shares of 2 different pizza chains. So we have Domino's Pizza and also Pizza Hut from year 2007 all the way to 2016. So how would you visualize this information? Yeah, I'll just give a a few more seconds. Just everyone have a think about it. So here's what we have gotten from the Wall Street Journal. So this is how one of the journalists have presented the data. So it's a bar chart that it's side by side for the different pizza brands. And you can see that it's actually using yellow for Domino's and Pizza Hut in green. Well, it's all okay, but because the color of the pizza chain that's really bright and it is a bit contrasting, and also the axis line isn't uniform in this case, so it could be really hard just to see the yellow because we have the bars that goes yellow, green, yellow, green, yellow, green. So it could be, it has a bit more cognitive noise in that sense to our visually. So if we were to redesign, maybe just rebuild this charts. So one of the ways to present this could be using the barbell charts. This is what we call the barbell charts. So we managed to keep the colors as well, but we have reduced it to very minimal. It still shows you the point where how much of the shares that Pizza Hut and Domino is dominating, and the line in the middle shows how much difference or what is the stark difference that these two chains have, and we can see that it's actually converging towards the years towards 2016. Or the other way we can present this would be a bar-in-bar chart. So here we can also clearly see the difference between the Pizza Hut and Domino's market share. And at the same time, because it is landing on the same year scale, just one single scale instead of a side-by-side bar, it's much easier for us to see the patterns of all the yellow blocks versus the green blocks. Yeah, but of course, when we are talking about to remove or to make it much comfortable for our eyes to visualize, you can actually soften the tones to change, to just change it to a more neutral tone for both ends. Yeah, so what many of you may think is that why not just draw a line chart? We are already all familiar with the line chart anyway. Well, it could, some of you may also think that it could be boring because we are actually using line chart day in, day out. So what about if we were to put in more information other than now we're just highlighting the starting value, which is 44 for Pizza Hut, and then the ending value, which is 31. We could also add the shading in between, so also to highlight the direction or the variance between the two. So the slope can tell us straight away if one of the areas is or some of the periods of the years the market shares are actually going up or going down. But some of you may notice, is there some more information that we are actually missing? Yeah, so what exactly would be the actual story? So other than Pizza Hut and Domino's, of course, there's also other brands of pizza chain. And by adding this to our diagram here, we can see that despite the gap between Pizza Hut and Domino's is closing, as we are looking near 2016, we can actually see that for other Pizza Hut chains, it's actually on the rise, way above these two pizza brands. So why not let's just group the Domino's and Pizza Hut into a single line. So it shows exactly the full picture of the information that we are looking at. So now the gray lines is indicating both a combination of the market share for both Domino's and Pizza Hut versus the rest. And if let's say because we have so many years of data, we might just want to have an overview of how the trends may look like just from the beginning till the 2016. We could also simplify and use the steepness of the diagram. So in this case, we're just plotting 2 points, 2007 to 2016, using what we call the slope chart. So this will indicate to us that throughout the years, what has the changes been. So Pizza Hut has a steep drop from 2007 all the way to 2016, whereas the others have a sharp increase throughout the years, while Domino's has a very minimal increase throughout the years. Yep. So if we were to remove the data, the other Pizza Hut chains data, we might be also presenting the wrong type of information or give our audience a incomplete or biased view or analysis. So really, to choose what to present in your data can be really, really important. And also the challenge here is that there is always more than one solution, definitely. So you have to decide not only which pre-attentive attributes are most relevant to your purpose, but that are also most relevant to your data set. So which data or which representation of the data best tells you the story that you want to convey to your audience? And what are the data that you want to keep, and what are the data that you wish to actually exclude? And also, do you need to show all of the data? So these are some of the questions that we might have to go through when we are building up our dashboards or doing our analysis. Yep, definitely. That's in the world of visual analytics, because many different people, for different purpose, they may have built the charts differently. So definitely, there's more than one solutions. So to bring it all together, we have looked at the different cognitive system, and we know that the power of our eyes and brains work together to filter out information that we don't want. We can also see tiny little change in the environment, which we can take advantage of if we use what we call the pre-attentive attributes. So I have another chart that is built in the 19th century. So this is a very interesting chart. This chart is titled as one of the greatest statistical charts that's ever done. And the reason that it is it's very impressive is because there's actually a lot of information that's that's presented here, but you will see that the chart or the graph itself is not exactly very cluttered. So what exactly is this chart for? Now, this chart tells us a history, basically, of the Napoleons trying to invade Moscow from the 1812. So let me tell you this story, and by just looking at this particular charts. So we can start off over on the left-hand side. So we can see here on the left-hand side, this is the Russian border. So the Napoleons have gathered an army of nearly 500,000 men, and they wanted to start marching to Russia, so which is at the far right, Moscow, here. So that's the starting point and the end. So the light brown shows the Napoleon's route, and the color shows its advances to Russia. The thickness of the line shows how many soldiers he had at each step along the way. So it is actually plotted sort of on a map, because you can see some geographical information like borders and so forth. So the colors would also show the direction of movement, latitude and longitude expressed by the route. The thickness shows that straight away this was a disastrous military invasion by Napoleon because he's losing soldiers at very rapid rates. Because the Russians at that point of time were employing brutal tactics to starve the Russians off their supplying lines. So things that's going on are like burning villages, evacuating villages. So most of these soldiers are starving. And eventually Napoleon's made it into Moscow. But the Russian actually they have already left or evacuated the city. So by the time the Napoleons have reached Moscow, they see that there's actually no one to fight with. So the Napoleons stay on for a moment, just for a while. But since there's no one to fight or conquer, they basically couldn't conquer Moscow, and then they started on their retreat. So that's why you see the black color line being represented. So black is showing the retreat. That's another pre-attentive attributes. So throughout his retreat, we can see that the line gets even thinner because in Russia at that point of time, it's the Russian winter, and definitely it's super cold in Russia. And how can we tell that? We can actually see that at the bottom of the screen, right at this area, it actually shows us the temperature of Russia at each step when they are going through. Yeah, so you can see the temperature is getting super cold as they move back in the direction towards the border where they came from. And in the midpoint where they lost a lot of soldiers, so it could probably be a river. So throughout, when they're crossing the river, perhaps half the soldiers have perished because either the ice wasn't thick enough and all of them drop into the water, or there wasn't much ice. And they cannot survive the winter simply because they have burned most of their boats in order to stay warm. So finally, when the Napoleons went back to the Russian borders, they are just left with 10,000 soldiers. So definitely, it is super disastrous military escapade. So we can see that this work done in the 1879 uses things like colors, position, slope, angles, and a bit of annotations to tell you the story just by using this data. But of course, in the world of visual analytics, there can be some debates or differences in opinions. So one of the best-selling authors, Seth Godin, has a comment that the chart we have seen earlier on is probably the worst chart that has ever made, because he thinks that there's too much information and people probably would not spend that much time looking at that chart that we've just actually gone through the entire history. So, is it true that the previous chart is bad? So let's take a look at it again. So now it all boils down to, again, who is your audience, and also what is the purpose of this chart that is trying to achieve. So the original author that has made this chart was trying to tell an entire history of what happens to the Napoleon when they are trying to invade Moscow. So without having us to flip through the thick historical book, we are able to tell or to find out so much more, and I've been able to tell you the entire story about this invasion so quickly just by looking at this chart. But of course, if we are doing a PowerPoint presentation that just needs summarizing of the information, then this definitely would be a horrible chart to make. Yeah, because it takes a bit longer time to find out what's going on here. So if we were only given a few minutes, then we probably want to make our presentation this way. So we are dumping it way down, and we're probably during the presentation we'll just say, okay, throughout the Napoleon or Russian campaign, 98% of them died and only 2% of them survived, and that is probably sufficient. Then if the executive needs more information, then perhaps we can go into the details. So it depends on what is really appropriate for your purpose of presentations. The charts that you build will basically be, your focus will basically be the purpose that you're trying to convey to your audience. So to recap what we have covered today, so also a quick reminder that when presenting data, firstly, of course, remember who's your audience, not just by the role, but also by the level of data literacy of your audience, and also what is the main purpose of information you're trying to present. We have also looked into our cognitive system and some of the concepts such as chunking and also our short-term memory. We have looked into basic building blocks of the charts that we built, which are the pre-attentive attributes, and not all of them are built the same. And of course, lastly, we found that there's also many different ways to present the same information. While there's no right or wrong, it mainly depends on the purpose of your dashboard and the kind of information or the feelings that you're trying to bring across, like the Iraq Bloody Toes chart example. So now that you have an idea about the visual analytics, why not try it out yourself? Take on a new perspective on your analytics and also your visualizations. Yeah, and also stay tuned for next week's second part of the series to find out how Tableau facilitates your visual analytics journey. You also see a demo of Tableau in the flow of analytics before showing you how Tableau makes it easy to visualize and also share insights in a way that's easy for you and your audience to understand. We have come to the end of the webinar. So if you have further questions, please feel free to type them in the Q&A box. We'll be staying behind for a couple of minutes to answer your questions in the Q&A box. Otherwise, thank you very much for joining us today. Goodbye.